morning everyone. So today we will start discussing about optics. Before going to that, let us discuss about what is light. If I am going to ask you, give me the definition of light, you will probably answer the form of energy or something like that. But in class 11, then in 11th standard, you will get the different definition of light. So what will be the definition for light itself? It is that part of electromagnetic spectrum which is having wavelength range from approx 4000 to 8000 Armstrong. In some cases this is given 38, in some books it has been given 276, I guess. Yeah, but this is a range only. So light is that part of EM spectrum, electromagnetic spectrum, which is having wavelength range from some Armstrong to that Armstrong. Okay, so here you will have a query regarding this. What is electromagnetic spectrum? So let us discuss with starting with electromagnetic spectrum. Electromagnetic spectrum or EM spectrum is assembling some rays. What are they? Gamma, X-ray, UV. Okay, let me just write it once. Visible, infrared, micro, radio, within which this we cannot see, this we cannot see, this we cannot see, cannot see, only this thing we can see, and this visible range is known as light. Okay, so what will be the range? The accurate range is this much, whereas in some book this is also given, so you have to remember all four quantities. Okay, this is the order increasing with lambda or wavelength, and from this to that end it will be the order of frequency, of course, right? Okay, okay, so this is all about your light. So this will be your new definition of light from today onwards. So if this is light, then what is optics? So optics is the scientific word which we are choosing for light. Same thing for sound also, we have chosen a different name, that is acoustics. Okay, so for light, optics, sound, acoustics. So these are scientific names which have been chosen. Okay, now in this chapter we will learn about ray optics and wave optics. Okay, so in ray optics, this ray optics is also known as geometrical optics, because here we are approaching each and every problem, each and every proof, we will deal with geometry here. So this is also known as geometrical optics. Okay, why this two particular names has been given to this segregation, to these categories? Because of the dimension of objects. Okay, which objects? So ray optics deals with mirror, lens, prism, telescope, These are the things, these are the objects which are in which we are dealing with ray optics, right? So these all are observable, and also the dimension of these objects are very big, right? And in class 10th you have already read about all these topics as a whole. So here we will discuss about reflection, refraction, this thing, right? And also one more thing here, the dimension of the object is much bigger, means it is com it is not comparable to the wavelength of light, lambda. Much bigger, the dimension of the object is much bigger, means it is not comparable to lambda, means it is much bigger than lambda. Of course, lambda means wavelength of light. This wavelength, how much is this? It is in Armstrong order, right? But the dimension of mirror rays lengths is much bigger. So this is the thing. One more is about wave optics. So in wave optics, the first thing is the dimension of the object which is comparable to lambda. Okay, so dimension of object, here object means what? We will write it later. Comparable to wavelength of light. Here the object is slits. Which slits? We will discuss here Young double slit experiment or diffraction at single slit. So here we will dealing with slits. What are the slits? Suppose it's a suppose I'm taking a black paper or a black cloth, okay, and I am piercing with a needle, or much more smaller dimension I'm taking to make a hole here. So now the black paper or that particular black cloth will be look like this. These things are known as slits, okay? And this slits, the dimension of the slits, dimension of the slits are comparable to lambda, means how small is that in Armstrong order? Not in Armstrong order actually, they are in nanometer order or something like that. So they are comparable, nanometer and Armstrong, this is the difference, right? So they are comparable. So this is the difference between ray optics and wave optics, and we will learn both of them. We will first go through ray optics and then wave optics. So which phenomena like reflection, refraction, which phenomena here we discuss about? Here we discuss about very interesting phenomena, and all are quantum mechanical phenomena, that is interference, 2 diffractions, 3 polarization. These topics we will discuss in wave optics. Okay, so let us start ray optics from here only. So ray optics, first we will learn about what are the properties. So one is light always travels in a straight line. I'm not going to write this. Number 2, you will pause the video and write it down in your classwork copy. The path of the light is called ray. The path of the light, okay, it's a straight line. The path of the light is called ray. Okay. Number 3, the collection of rays are called beams, right? Or beam of light, not beams, beam of light. Okay, collection of rays are called beam of light. So this 3 point we have to understand, you have to remember. Other than that, number 4, it is an electromagnetic wave. Number 5, it is a transverse one. So these are the things you have to remember. Okay, so up to this, you know, up to this thing, right? In light, in class 10 you have learned about these things very clearly. Now let us learn about reflection. Reflection. Whenever you are going to ask this question, what do you mean by reflection, you always, your idea, your thought always revolve around this picture, right? You will draw this picture in no time, right? Incident reflection, okay. Laws of reflection. I'm not good with the camera or handling in camera, so you have to have patience. Okay, so first law is angle of incidence, angle of is equals to angle of reflection. Another one, reflection. Another one is incident ray, reflected ray, and the normal drawn at the point of incidence are always lie in the same plane. This thing, these two things we know. Okay, and this thing you have to remember very carefully. Okay, you know all about this. So in the first video I'm not going to deep concept or something like that, only an overview I will give you. Second is about the normal reflection. Okay, normal reflection. From class 8 you are learning these things. From class 10 a bit elaboration, and 12 you have it all. Okay, in normal reflection, this is your mirror and this is your angle of incidence. Now if this is your angle of incidence, where you have to put your normal, you have to put your normal along this line only, right? This is your normal only. And what is the angle between these two? These are all in same line, so that there is no angle between normal and incident ray. There is no angle. Here it is an angle I. So here we have a written angle I, something, it is having something value. But here there is no angle between the normal and the incident ray. So I will become 0. If I is becoming 0, then according to laws of reflection, R will also be, right? So in this way we can write. Last, which is more vital to say, and this is from your class 11th topic, that is how we will find out the angle or the normal in case of a polished spherical surface. So is this for a plane mirror? Okay, this things. If I am taking this type of mirror, then what will happen? Suppose this is a circle and this is center of the circle. Then what will happen? If this is your incident ray, okay? So always remember, from the center you have to take the normal, okay? So this will be your normal. So this will be your IR. Okay, so in case of this type of spherical mirror, you have to take normal from center. Okay, or we can write in this way, normal should pass through the center of the sphere. Okay, now if I'm going to draw something like for point object, this thing you also know. Okay, anyway, O. Suppose it is in L distance apart from the mirror, away from the mirror. So of course here the image will form, but in what way you have to draw it, right? Right? As if, in case of this particular thing, as if this ray is coming out of O prime. right? The point O prime. So this will be the image which is known as virtual image, because it is appearing like, here should be your eye, it's appearing like the light rays are emerging from the point O prime, not the point O. So this, of course, this image is the virtual image of the object O, right? So this thing you know it all. Suppose I'm giving you another question. This question you have already done in class 8. Suppose here, this is your mirror and it ends here, okay? But you have drawn an object here, okay? This thing you have done in your class 8, and this is in your NCRT book itself. If you go through Paheli, Bojo and that thing, okay, anyway. So where the image will form, if I'm, see, in a room, you can see object from here only. If you look at the mirror, you can see this object from here, right? So we can see this object. If even if this is not in front of mirror, the image will form. Then how the image will form? How will we write? How will we draw this image? We will extend the mirror. Suppose this is L, distance from the mirror, and from back this is L. So here, of course, the image will form. But how would you explain that? You will take a ray here, normal, it will go there, right? And okay, another ray, suppose here, and right. So here anybody can see, right? So as simple as that. So this will be your, okay, so up to this we will be discussing today. We have already discussed it today. Okay, so let me just rewind it once more for you. After that I will be giving a question and you have to solve it by your own, and this will be your homework question. Only one question I will give. So what is optics or what is light? It is that part of EM. I'm just revising the keywords for you, okay? So light, it is that part of the EM spectrum, which is having the wavelength range of 4000 Armstrong to 8000 Armstrong, okay? And you have to remember this range only, also. Okay, then what is EM spectrum? EM spectrum is comprised of this thing: X-ray, gamma ray, UV, visible, infrared, microwave and radio wave, within which only this part is visible, which we are referring to light, okay? And what is the range? This two range you have to remember, because in different several books different thing is given. I don't know what is in NCRT. You can follow this, okay? Okay, so this is gamma, X, UV, visible, infrared, micro and radio. This is increasing order of wavelength lambda, and this is increasing order of the frequency, okay? Because frequency and wavelength is inversely proportional. So of course, if this is increasing of wavelength, this will be increasing of frequency, okay? Reverse one. Next is optics. We will discuss two optics, ray and wave. In ray optics, all the things we have done in class 10, just elaboration you will study here, okay? So ray optics, also known as geometrical optics. Here you have to remember one single keyword, that is the dimension of the object not comparable to lambda, okay? Dimension of object is not comparable to lambda, okay? Wave, in case of wave optics, the dimension of the object is comparable to lambda, where it is written comparable to lambda, okay? What are the things we are going to study here? You need not to remember it, you will learn it eventually. Reflection, refraction for ray optics, wave optics, interference, diffraction, polarization, okay? That's it. Now in next part, ray optics, what are the properties? In straight line it is always moving. Ray, what are the rays? Beams, collection of rays, EM waves, that you know, okay? For plane mirror, reflection you know, this thing, just you rewind once, I know you can answer it pretty well. Okay, in case of normal reflection, what is happening? Both are zero, incident and as well as the angle of reflection. But the main point, the basic point is here and here. First is, in case of this type of mirror, if the inside uh, a circle, in not a circle, a sphere, suppose a sphere, this part, outside part, an incident ray, an angle ray of light is incident, okay, then how will you draw the normal? Normal always pass through the center. Normal always pass through the center. Okay, next, in case of point object, this thing you have done, I'm not repeating this once. Last is this one. Okay, for this thing, see, if the mirror is ending here only, okay, and the object is placed after that, then what will happen? In same position, suppose it is 2 centimeter apart, this will also 2 centimeter apart, okay, right? The image will form. How the image will form? Where the image will be seen? From here the image will be seen, up to this. Okay, so following this thing, this is a hint I am giving. Okay, you have to answer this following question. If the coordinate of, I hope it is missing, coordinate of an object placed in x-axis is 2, 0, then what will be the coordinate of the image? Okay, I'm giving you the answer. The answer will be 0, 2, and the reference figure is y-axis, x-axis, minus x, minus y. Okay, so the object position has been given. So object is here at 2, 0. You have to find the image position along with the image dimension. Okay, I hope it has been seen.